Hello everyone. In this video, we're going to be solving a nice system of differential equations. If you remember, last week I had told you that I was going to try to bring a system of differential equations, maybe sometimes differential equations, once a week, and I'm going to try to bump up the level of difficulty as much as I can. Once in a while, we're going to do some easy problems here and there, but hopefully when this is complete, you're going to get to see a bunch of different systems. And let me know what you think about this project or idea so I can adjust it. Great, so now let's go ahead and take a look at this equation, and we're going to talk about what makes this equation different, or the system different from last week, right? So we have dx over dt, which is 5x plus 2y plus 5t, and dy over dt is given similarly. What makes this equation different is that last week, I think it was on Monday too, we didn't have these terms where we have the variable, right? The dependent variable. In this case, because we're talking about x is a function of t and y is a function of t, so t would be the independent variable, actually, to be honest with you. But anyways, you get the idea. We didn't have those. Now we do have them, so how is this going to be different, right? Obviously, this means this equation is non-homogeneous, which makes it a little harder, but at the same time, more interesting. Anyways, let's go ahead and get to work. For simplicity's sake, I'm going to go ahead and use the x prime, y prime notation. By no means x prime means 1, because we're not differentiating with respect to x. We're differentiating with respect to t, okay? So x prime means dx over dt, and y prime means dy over dt. So in this case, x prime is given as 5x plus 2y plus 5t. So here's my goal. My goal is to get rid of y completely and to come up with an equation that is only in x so that I can solve it. Of course, there's going to be t in it too, but I'm talking about the dependent variables, okay? Great, so we're going to start with the first equation, x prime. And guess what we're going to do from here? We're going to solve for y, because I'm going to need it later on. When I need to substitute something for y, I'm going to need this. So let's go ahead and isolate 2y from here. You can basically subtract 5x and 5t from x prime, and then divide both sides by 2 or multiply by 1/2, which is actually better in this case. Let's go ahead and do that to isolate y. So y in terms of x and t. Great. This is something that we're definitely going to use later, so let's go ahead and save it for future use. Okay? Now, this is y. Now, here's what we're going to do. We're going to go back to the first equation, which is x prime equals 5x plus 2y plus 5t. And this time, we're going to go ahead and differentiate it. Now, why do we need to differentiate it? Because this is going to bring us x prime, which we already know what it equals, plus this is going to bring us y prime, which we can also figure out. Okay? So let's go ahead and do that now. We're going to differentiate it. So we already have x prime. So the derivative of the first derivative is just going to be the second derivative of x, which is x double prime. Again, this is with respect to t. And then when you differentiate all of these, the derivative of 5x is just going to be 5 times x prime. Because remember, this is kind of like a 5u. Think of it that way. And how would you differentiate 5u? That would be 5u prime. Okay? And then 2y is just going to be 2y prime. And the derivative of 5t with respect to t is just 5 because it's with respect to t. Make sense? Great. Now, what can we do at this point, right? We want to turn everything into x. So we got y prime here. So do we have an equation for y prime? Yes, we do. The second equation gives us y prime as 3x plus 4y plus 17t. So now this is something that we can substitute here. Again, our goal is to turn everything into x, but it's going to contain some y, which we're going to take care of later. You already know how, right? X double prime is then 5x prime plus 2 times y prime, which is 3x, plus 4y plus 17t plus 5. We can go ahead and simplify this a little bit. X double prime equals 5x prime plus 6x plus 8y plus 34t plus 5. Great, it's a jumbo mumbo, right? We have x prime, we have x, we have y, we have t, we have everything. All right, great. Now, we're going to go ahead and replace the only thing that doesn't depend on x, because again, x is a function of t, so t is okay, but we want to change this y and turn it into x. And we can do that by using what we just found. Remember, we were able to isolate y, so now we're going to go ahead and replace y with that. So now we're going to replace y with, of course, don't forget the 8. We're going to replace y with 1/2 of x prime minus 5x minus 5t. That's basically going to replace y, and then plus 34t plus 5. Of course, 8 and 1/2, they're going to cancel out, leaving us with a 4 here. And then I'm going to go ahead and distribute the 4. That's going to give me x double prime in a nicer way. 5x prime plus 6x. And then if you distribute the 4, you're going to get 4x prime minus 20x minus 20t plus 34t plus 5. And when you simplify this, you're going to get what you need. 5x prime and 4x prime together gives us 9x prime. 6x minus 20x is minus 14x. These two will give me plus 14t, and then finally plus 5. Now notice that we got what we needed, right? X double prime, an equation in x only. There is no y or y prime in this equation, so we're good to solve, okay? How do you solve it though, right? This is where the non-homogeneity come in. Why is this non-homogeneous? Because if you put everything that contain x on the same side and everything else stays where they are, like this, you notice that we don't have 0 on the right-hand side. If we did have 0, that will be homogeneous. But don't worry, this equation can still be solved because the left-hand side is linear. What I mean by that is we don't have x squared, or we don't have x prime squared, or we don't have x double prime squared. So nothing is raised to the second power on the left-hand side, and right-hand side, we don't really care that much about it, okay? Now, how do we solve a non-homogeneous system like this, or non-homogeneous equation rather, right? So here's how we can do it, and we've done some similar problems before, and this is where this problem differs from what we did last week, and you can go ahead and check it out. I'll probably maybe even make a separate, should I make a playlist for this, like a system of differential equations? But I already have a differential equations playlist anyways. So we're going to consider the homogeneous case first. So here's how it goes. We're going to solve the homogeneous case. That's going to give us the homogeneous solution. And then we're going to try to find the particular solution, right? Or some type of complementary solution for the right-hand side, which is probably going to be something linear in T. And then we're going to put it together because the general solution is made up of the homogeneous solution, which is YH, plus YP, which is the particular solution. That's what we're going to try to get, okay? But let's go ahead and focus on the left-hand side. If you go ahead and replace x with e to the power kt, because x is a function of t, you're going to get something like this. You're going to get from the second derivative, you're going to get k squared e k to the t. And at the end, you're going to get something like this. And you can actually kind of automate this too, because this will give you what's called the characteristic equation. So this is the only thing you need to focus on. Don't worry about this because this is not going to be 0. So now we have to solve it. Now, how could you get that directly from here? By using the differential operator, you could actually write this as d squared minus 9d plus 14 applied on x, this is the differential operator, equals 0. And now this means the second derivative, this means the first derivative, this just means multiply x by 14. That's what we did, right? So, and from here you can get the characteristic equation directly, k squared minus 9k plus 14 using the exact same coefficients. Make sense? But this is factorable into k minus 2, k minus 7. So from here we get k equals 2 and k equals 7 as our roots. Roots of the characteristic equation give us the value of x. So x of t can be written as, with the coefficients of course, c sub 1 e to the power 2. I was about to write x, but that's supposed to be a t, plus c2 e to the power 7t. So this gives us the homogeneous solution, right? Great. Now, how do we find and if you want to put a little h here, that's fine. How do you find the particular solution? So for a particular solution, I'm going to try something linear because notice that the right-hand side is linear, 14t plus 5. So why not try something like at plus b? And of course, my goal is to differentiate this once and then one more time. That's going to give me a and x double prime. And you don't have to write x sub p. Every time you can just write x double prime. And of course, I want to go ahead and plug it into this equation. Which equation? I want to plug it into my equation, which is the non-homogeneous case. Let me go ahead and rewrite it. X double prime minus 9x prime plus 14x is equal to, what was the right-hand side? 14t plus 5. Now I'm going to go ahead and plug these in. I also have x, so I have to use this as well. X double prime is going to be 0 minus 9 times a plus 14 times x. X is going to be at plus b. And of course, I want this to be true for all values of t. So we're going to get a polynomial identity, right? This is going to give us 14at. And then we can go ahead and actually 14at minus 9a plus 14b equals 5. And then from here, like, how do you, okay, so here's what you're going to do. You're going to look at the coefficient of t, and then you're going to look at the constant. In this case, the coefficient of t is 14a. Oops, I forgot to write 14b plus 5. I don't know why I just wrote 5. So this is what I'm supposed to get. Now notice that this is supposed to be 14. So from here, a is equal to 1, right? And then the constant term is supposed to be 5, but a is 1. So b is also 1, which means x sub p, or which the particular solution is supposed to be t plus 1. And since the general solution is made up of the homogeneous solution plus the particular solution, we're going to put those together, c1 e to the 2t plus c2 e to the 7t plus t plus 1. When you plug it in, you're going to realize that this satisfies the equation. All right? Now, here's what you're going to do. Let me just tell you what to do because the rest is yours. To find the solution for y, we're going to go back to this equation. Remember, y was isolated as 1/2 times x prime minus 5x minus 5t. Since you already have the x, you can go ahead and plug it in. You can differentiate this to find x prime. Of course, you have to do it with all the coefficients. And then from here, you're going to find the y value. But let me go ahead and tell you what the y value is also going to be so that you have the full solution. And hopefully, you can also check your work. C1 e to the power 7t minus 3 over 2 C2 e to the power 2t, or not 2t if you're a tutor, minus 5t minus 2. And that's going to be the x value, the y value, and this is going to be the y value, and that's the other one is going to be the x value, and you can kind of, if you want, you can go ahead and check your work with this. And this brings us to the end of this video. Thanks for watching. If you enjoyed it, please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. By the way, don't forget to check out my shorts channel as well as aplusbi, which is a channel focused on complex numbers. By the way, on Wednesday, I'll publish another video on this channel, and it's going to be a surprise. Let me not tell you what it's going to be about. But wait for Wednesday. See you next time. Bye-bye.